Hi everybody. So in this video I'm going to show you how to prove the formula for a geometric series, which is this formula here, and then later on I'm going to show you how to apply that to various problems. So to begin with proving this formula, we need to look at the general geometric series. So the sum will be the first term plus the second term, which is a times the common ratio r, plus the third term, a times ar times r, so ar squared, and we'll carry this on to get to a penultimate term, ar to the n minus 2, and then the final term in this series, ar to the n minus 1, and we'll call this series 1. So now to find this formula, what we need to do is we need to multiply series 1 by r, so we get r as n, and then we'll have the a times the r, which will become ar times r becomes ar squared. The third term will be this 1 times r, so ar cubed. Then we'll have all the middle terms in between. We multiply this term by r, we get ar to the n minus 1. And then the final term by r, we get ar to the n, and we'll call this series 2. So now to find the sum of these two series, what we can do is series 1 take away series 2. So we'll have Sn minus Rsn. Then we'll have A, and there's no A term in the second series, so A. And then the AR, when we subtract that from this one, these two will cancel. These two will cancel, and all the middle terms will cancel. AR to the n minus 2 will cancel with the 1 before this one, and this will cancel with this one. So what we're left with is A minus AR to the n. So now we can find the sum of a series, Sn, by factorizing the left-hand side. So this becomes 1 minus r. And we can factorize the a out of the right-hand side. So we get a lots of 1 minus r to the n. So now we can make Sn the subject, divide both sides by 1 minus r. So Sn will be a multiplied by 1 minus r to the n over 1 minus r. And this is the formula for the sum of a geometric series. In example 2, I'm going to show you how to use this. Okay, so in example 2, we've been asked to find the sum of each geometric series. So for example A, we've been told that the first term is 3, so we'll say that A equals 3. The common ratio will be the 6 divided by the 3, which is 2, and 12 divided by 6 is 2, 24 divided by 12. So this gives us the common ratio, and we know we've got 8 terms, so n is equal to 8. So the sum of the first 8 terms will be A, using this formula, multiplied by 1 minus r, which is 2, to the power of n, which is 8. We'll close that bracket, and then we can divide this by the 1 minus r over 1 minus 2, which is negative 1. We can work this out on our calculators, and we get 765. So for question B, well, again, we know that A, value in this time is 2. The common ratio will be the negative 4 divided by 2, so negative 2. We can check this by doing 8 divided by negative 4, which is also negative 2. So this gives us the common ratio. We've been told we've got 10 terms, so n will equal 10. So the sum of the first 10 terms will be A multiplied by 1 minus the r. It's a good idea to have a negative 2 in brackets to the power of 10. We'll close that bracket, then we'll divide it by 1 minus the negative 2. So this becomes 2 lots of 1 minus negative 2 to the 10 all over 3, which gives us negative 682. So for example C, this time we're being told A is a half. The common ratio would be a quarter divided by a half, which is a half. And the number of terms we're looking at is 9. So the sum of the first 9 terms will be a multiplied by 1 minus r, so 1/2, to the power of 9, all over 1 minus r, so 1 minus a half. And we can simplify this because this half will cancel with this half. So we've got 1 minus 1/2 to the 9. And this gives us 511 over 512 exactly. Okay? So in example 3, we're going to look at using this formula to find the number of terms in the series when we know its sum. Okay, so for example 3, we've been asked to find the number of terms needed for the sum of a geometric series, this one here, to exceed 1.5 million. So the first thing we need to think about is the information we've been given. We know that A is 3. We know the common ratio is 3 times 2, 6 times 2, so R is 2. We're trying to find N, but we do know the sum of the series is 1.5 times 10 to the 6. So we can put this into our formula. We've got 1.5 times 10 to the 6 is equal to A multiplied by 1 minus R to the N over 1 minus R. So because I've got a negative denominator, I'm going to multiply this fraction by -1. So we'll have 1.5 times 10 to the 6 is equal to 3 lots of 2 to the n minus 1 over 2 take away 1, which is 1. So this is much easier to deal with than this one. Now we can divide both sides by 3. So now we get 5 times 10 to the 5 will equal 2 to the n minus 1. We'll move this -1 to the left-hand side. So 500,001 equals 2 to the n. Now to find this power, we need to apply the rules of logs. So we'll take the log of both sides. And when we take the log of this side, then we can pull this n down using the power rule. So this becomes n the log of 2. Now we need to divide both sides by the log 2. We can work this out on our calculator, and we get 18.93, and this will equal n. So we want the first term to exceed 1.5 million. So this doesn't quite exceed it. So we're looking at the 19th term will be the first term to exceed 1.5 million. Okay? Well, thank you very much for watching, and I hope you found that useful. If you did find that helpful, please like and subscribe. And you can download the full lesson and worksheet from our website, mrmathematics.com. There's a link in the description below. Thanks again, and take care.